So when we talk about a derivative, right, we talked about what a derivative is, right? We're spending this whole chapter on how to find a derivative. So that question, how to find a derivative, we'll answer as we go. But what a derivative is. 3 words, or it could be more than 3, but 3 words I'm looking for. What is a derivative? There you go. Slope of a tangent line. Those 3, slope, tangent, line, right? It's a slope. It's a rate of change. What is a slope of? A tangent line. And we talked about what a tangent was yesterday. Okay? So the last 2, what they're going to ask us to do is they're going to ask us to find an equation of a line. Equation of a tangent line. Well, equation of a line. You probably haven't done this in a while. So let's go over what's the equation of a line? So there's 3 forms, but I'm only focusing on 2. There's 3 forms. Slope-intercept, y equals mx plus b. It's the one that's stuck in the back of your head since 7th grade. That's, y equals mx plus b. That's the one thing that kind of sticks, right? M is slope, b is y-intercept. That's one form. The other form that we're going to use quite a bit in this class is called point slope. Point slope. It's called point slope because it has a point. That's what the x1 and y1s are. They make a point. And the slope. Okay? The other one's standard form, but we don't really use standard form in this class too much. We don't. So standard form's the other one. It is a form, but I'm not really going to spend time on that. So those are the 2 forms, right? So we're going to decide. So what we need to do is give an answer that's either in slope-intercept or point-slope form. Okay? The question here says equation of a tangent line. Does it say which equation I have to use? Does it say I have to use slope-intercept or I have to use point-slope? No. So it could be either one. It could be standard form too, but standard form's a little hard. It's unnecessary, okay, for what we're doing. It's not hard, but it's just it's extra steps we don't need to do, okay? So that's what we got to do. Well, what do they both have in common? What do both forms have in common? Slope. So we need slope, right? We need slope. Derivative is a slope of a tangent line. So that's how we're going to find slope, is through finding the derivative. Okay? And we either need the y-intercept or we need a point on the graph. Either one. Okay? So we'll decide that. We'll do that last. But for right now, let's look at this. Okay, so f of x. So the function is 1 over x. 1 over x. So we need to find derivative first, right? Okay, so let's write derivative. F prime of x, because that's another word for derivative, right? Prime, we talked about that prime yesterday. Okay, so let me write the definition. The limit as h approaches 0, it's written right behind me too, and on the other side of your notes. F of x plus h minus f of x over h, right? That's the definition. That's the general definition. We're going to use it for this problem just like we've done the last 2. Okay, so let's start with the easiest part. Easiest part is f of x. 1 over x. It's just the original function. 1 over x. Good. H is on the bottom. What does f of x plus h mean again? What is that? It's a command. What is it telling us to do? Plug it in wherever x is. Plug in what? X plus h, wherever x is. That's on the bottom, right? Okay. So 1 over x plus h. Okay. So what happens if I plug in 0? What happens if I plug in 0 to answer the limit right now? What will happen? It would be 0 over 0, right? Because 1 over, if I plug it in for h, it would be 1 over x minus 1 over x over 0, right? So that means I have work left to be done. So we're going to go back. This is actually what we did in the first chapter, right? We looked at guys like this when we were trying to find limits. What did we do? Does anyone remember what we did last chapter to this type of limit question? Not factor, you're close. That was one of the methods. Factoring was one of the methods. We're not going to factor this one because there's no x squareds and x to the thirds and stuff like that.
Multiply?
Not multiply, multiply by the conjugate. We did that when there were roots involved, right? When there were roots involved, we did multiply by the conjugate. There's no roots here. The last one was common denominators, common denominators. So what I'm going to do is I'm going to focus on the top. So I need the common denominator for both, right? Well, the first one is a binomial. Second one is a monomial. Right? Common denominators means equality. Make them the same. Or not equality, but make them the same. Right? So the first guy has a binomial x plus h. What is it missing? Is it missing an x?
No.
It does have one, but x plus h is a number. X is a number. Are they the same number? No. So even though they both share an x, they're not the same number. So what I have to do is I have to multiply this guy by h, this guy by h. X, sorry. Said h, had x in my head. It's x, yeah. The other guy. That one needs an x plus h. X plus h. X plus h. Okay. So now the top. We're going to have one fraction. What is our common denominator between the two fractions? X times x plus h. Okay. H is still on the bottom. The first one.
Why did they give it moved down the bottom?
What do you mean I moved
You know the x times x plus h, that's the top one, right? Over there. Oh,
No, they're on the bottom.
He hasn't put in the actual top.
Yeah, I'm putting on, yeah. I haven't finished. X times 1 is x, right? And then I got to distribute here. Distribute. When I distribute, what am I distributing? A negative 1, good. Not a positive 1, a negative 1 because of that minus. So it's going to be negative x minus h. Negative x minus h. What's going to happen to the x's on the numerator on the top? Yeah, they're going to cancel out. Okay, so let me rewrite what I got. Yeah, it's still going to be negative h, yeah. The limit as h approaches 0, I have negative h on top, I have x plus h on the bottom, h on bottom. So it's called a complex fraction because it's a fraction on top of a fraction. There you go. That's what we did, right? We multiplied by the reciprocal or keep, change, flip, right? We took the top fraction and divided it by h, right? So when you do that, the top fraction is going to stay. Division is going to change to multiplication. H will flip, will be a reciprocal. Keep, change, flip. We did this last chapter as well. So it would be negative h over x plus h times, and then flip h. When I flip h, it'll be 1 over h.
Should become h because it's on the bottom.
But is it h or is it 1 over h over here?
It's 1 over h.
No, it's h.
Wait, isn't it under the first square? Isn't it top?
No, so actually this guy is written like this. Watch. This guy. Another way to write that guy is like this.
H is being divided by.
Yeah, it's division. X plus H divided by H. That's what's going on. So that way is a little more clear. It's just H. Yep.
Because then it would be a 1 under.
Exactly. Okay. All right. Multiply straight across. I get negative H over X times H times X plus H.
Do we always have to write the multiplication sign? Or
No.
can we just write X?
No, yeah. I just do that just to reinforce it. It's just XH. What can I cancel out?
H?
H, yep. So be careful when you're canceling out simplifying H's, right? Can I do that one and that one? No, because the bottom one is part of the binomial. So I can do that one and that one. Because those are monomials. So this is -1, right? So let me bring it back to where the limit as x approaches 0. What I have now is -1 over x plus h.
Then you can plug in,
Now I can finally plug in 0 for h, right?
and then you can plug in 1 for X too.
I'm not even going to plug in anything for x. I'm going to leave x alone. Because the limit says plug in h as h approaches 0. So if I plug in 0 here, what's x plus 0? X. What's x times x? There you go. So the derivative is -1 over x squared. That's the derivative. So let me go write this over here. The derivative of the original function f is -1 over x squared. That's not what they were asking for, though. Remember, the derivative is a tool. It's a tool to help us get the slope. So now what I'm going to do is they want equation of a tangent line at 1. So what am I going to do with 1? Plug in 1 to the derivative. So f prime of 1. -1 over 1 squared. Which is just -1, yeah. So the slope of the tangent line at 1 is -1. So now, yeah, that's where we finished the last problem, right? But we're not done on this problem because they want an equation. Okay, so let's go back to our list of equations again. Do I have a slope at 1?
Yeah.
I do.
So you're plugging in M.
So which one? So yeah, so I'm going to plug it in for m, but it depends on which one I use. Do I have a y-intercept? Do I know anything about a y-intercept for f of x? No, they didn't tell me, and I haven't figured it out. Do I have a point?
Yeah.
I have half a point, right? That's more than I have up here. So what I'm going to do is I'm going to use point slope. So my question is, I got an x, right? That's 1. I got an m, that's -1. How do I get y? Easier than you think. To the, plug in what to what? You're right. Plug in what to what?
Negative the slope to the slope.
Not the slope, you're close. Plug in your x value into the original. The original. Yeah, I'll get y. Okay? So yeah, it'll just be 1 over 1. Yeah. So one more time so that it can be clear. To get the point, because it's a point on the original function, you're going to take your x value, 1, right? They told us x equals 1, and we're going to plug it back into the original, right? That'll give us the y. We don't need the slope anymore. We got the slope, okay? So let me see. So let me go f of 1 equals 1 over 1, yeah. So it's just 1. So f of 1, So what's my point?
1, positive 1.
1, 1.
1, 1, yeah. 1, 1. There's my point. There's my slope, right? This is M. This is my point. I have a point and I have a slope. Makes sense to use point slope. Okay? So point slope is y minus y1 equals slope x minus x1. X1 and y1 are the point, right? What did we say the point was? 1 comma 1. So x is 1, y is 1. Slope is negative 1. It's in point slope form.
That's all we do.
That's it. We got an equation of a line. Didn't say it needed to be in a specific form, so we'll use point slope. Okay, so let's before we go on to the next one, I'm not so worried about the x plus h, all this stuff, because that's just practice. Like we talked about, more foundational skills. I'm worried about how did we get from, what did we do? What were the steps? What was the process? So the first thing, what was the first thing that we did when we did this problem?
Define if it's 0 over 0, so we just plug it in.
No. What did we do? What's the first thing?
Here's the equation.
What's the first thing? We found the
Derivative.
derivative. We found the derivative. That was all of this mess up here, right? And the derivative was negative 1 over x squared. Find the derivative. That's the first step. What did we do with the derivative? Found the slope. How did we do that? Plug in the x value to get the slope, right? Plug in the x value to get the slope, negative 1. What did we do? What was the last thing, or what was the next thing we did?
Find which equation.
Found the points.
The points, right? Found the points and then plugged it into the equation, yeah. Okay? Because that process that we just did right there, you're going to do a lot. You're going to do a lot of. Now, like I told you guys, I promised you guys this, and I promise you on Tuesday, I will teach you different methods. This problem here, I don't know, what did it take us? It took 15 minutes or so. This problem next week will probably take you 2 minutes, 1 minute. Because there are other rules for finding derivatives, we just haven't done those yet. So I promise you, the process won't be like this all chapter long. It will not. It'll go by a lot faster. But I want to use this method first because it's important. It is important. Okay? Okay, so we're going to do number 4 for sure. If we have time, I'll give you one more problem to try on your own, and then we'll be done for today. Okay? Okay, so here we go. Number 4. So before I actually do anything, I like to look for cues. I like to look for something in there that's going to tell me what I'm going to do. Okay? So what do you see in the question that's going to tell me what my first step? Because the first step's always the hardest. What do I do first? What's in there that's going to help me?
Equals x squared minus 4.
That's the original. Okay, what am I going to do with that guy?
Find
Plug
the
it
equation.
in. Plug it in to x.
No. That's maybe down the line. But what am I going to do? Anytime I'm doing this problem, there's always going to be an f of x. There's always going to be an f of x. Every problem you have is going to have an f of x or a g of x or an h of x. There's always going to be something like that. You can always count on that. The part that's going to be different a little bit is what are they asking you to do with it? There you go. They want an equation of the tangent line. There's always going to be these two guys I'm boxing, right? These two guys, there's always going to be one of those two guys. These guys are not new. We've seen them on number 1. We've seen them on number 2. We've seen them on number 3. What's different is this part here. They want an equation of a line, just like we did on the last one, right? to make an equation of a line, I need these things. I need a slope, and I either need a y-intercept or I need a point. Okay? Start with the slope. How do we find slope of a tangent line? One word starts with a D.
Find the derivative.
Derivative. Okay? So let's go back. Oops, not that one. This one. Okay. So we need to find f prime. Oops. So f prime is a limit, the limit as h approaches, sorry. H approaches 0. Yeah. Why do they use m for slope?
Do we have to write that on the top?
That's a great slope. What's that?
Do we have to write the limit of h as 0?
If you're using the definition, yes. If you're using the definition, yes. If you're not using the definition, no, you don't have to do it. It's a limit question. Okay? So here we go. Okay, so we have h on the bottom. If we're using the definition, h is always on the bottom. And then where do we start here? The original, yeah, put that there. I'm going to put it in parentheses since it's a binomial. And I'm subtracting both of them. I'm not just subtracting x squared, I'm subtracting x squared and negative 4. Okay? Now, how do I build this guy? How do I build fx plus h? Yep, plug in x plus h where x is. It's only in one spot. So that's going to get parentheses. X plus h squared minus 4. You could. It doesn't hurt. I'm not going to because I usually don't. If it's a front of a subtraction, I usually don't. But you could. It doesn't hurt. I usually only put parentheses after a subtraction sign, if it's a binomial especially, because it reminds me to subtract both of them. Okay, so we did kind of one like this yesterday. So you can distribute, right? I can distribute. Let me distribute this so I don't forget. What is this guy? What does x plus h squared mean? Quantity squared. Times itself, right? So let's do that first. X plus h times itself minus 4, because it was the minus 4, and then when I distribute it, I get negative x squared plus 4. What should I do next? We did one like this yesterday.
Foil.
Foil or multiplication box, right? With these two binomials. If you're multiplying binomials times each other, FOIL, first, outer, inner, last, or multiplication box, whichever you're more comfortable with. First two terms, outer two terms, inner two terms, last two terms. Okay. First two terms, x times x, x squared. Outer two terms, x times x, or x times h, xh. Inner, xh. Last, h squared. So yeah, so start canceling things out, combine like terms, cancel things out, or just combine like terms.
Squared and the 4s?
Mm-hmm. X squared goes away, x squared goes away. Negative 4, positive 4. And then I can combine like terms, right? Combine these two guys. If I have one of them here and one of them here, if I put them together, I got two of them. Two xh plus h squared over h. Yep, there you go. all three terms. I have two terms on top, one term on bottom. They all got h's. So I can factor out an h from the top. That'll take away an h from 2x, and it'll take away an h from h squared.
And the h is times what?
Simplify those to be ones.
2x plus h.
So yeah, so now let's bring back the limit, right? F prime of x equals the limit as h, God, why do I keep writing x? H approaches 0. What do we have left? 2x plus h, right? After we plug in 0 for h. So do the limit. What's the limit after I plug in 0? What do I get? 2x. So the derivative for the original function was 2x. Most likely we use point slope, yeah. Rarely do they ever give us a y-intercept. So usually the easier one is point slope. Before we go on to the next step, have we got a derivative of 2x before? Check your other problems. Did we ever get a derivative of 2x for any of the other ones?
Yeah, for number 1.
For number 1, right? If you know the answer, don't answer. But if you're most calc students don't know the quicker methods on how to find derivative. But if you do know the quicker methods, don't say anything. What do both of those guys have in common? What do number 1, f of x for number 1 and f of x for number 4 have in common?
H squared.
An x squared. So it looks like anytime I have an x squared, the derivative is going to be 2x.
So even if it was like plus 99, it'd still be 2x?
Keep that in the back of your head. Yeah, we'll talk about that next week, but just keep that in the back of your head. Yeah, because we're going to come up with rules next week so that we don't have to do all of this mess. We can go right from here to here. Next week, you literally will be able to go from here to there.
I mean, it's just really tedious. It's not really that complicated.
No, it's not hard. It's just tedious. Yeah, it's exactly right. Yeah. Right? But yeah, so after next week, you'll be able to go boop, boop. Okay? Okay, so we got a derivative. I have the derivative. What do I do with it?
Plug in x to get the slope.
Plug in x value to get the slope.
And then find the point.
The x value is 12, right?
12 times 2.
So 12 times 2 is 24. So the slope of the tangent line at x equals 12 is 24.
Which is extremely positive.
Yeah, extremely positive. Increasing very fast. Up 24 over 1. So that's almost a vertical line. Okay. All right, so now, last thing, or no, second to last thing, we need a point, right? I need a point.
Which you just plug x into the original equation.
Here you go. Plug in x to the original equation.
And you get 2.
And we get 20? No, we're going to be bigger than that because it's x squared. 140, right?
Oh, squared. Oh.
Yeah, because f of 12 equals 12 squared minus 4. 144 minus 4 equals 140, yeah. So right 12, up 140.
So the ones would be 12, 144.
Say it again.
0, the ones would be 12, 144.
That's the point, right?
Is the point always going to be the same as the slope?
What do you mean, what part?
Because for both of the equations, we plugged 1 into x. Or the x equals to x, so is it always just going to equal the slope?
So we plugged in 1, I know we plugged in 1 the last one, right? Because it was x equals 1. But we didn't plug in 1 this time, we plugged in 12, right?
Yeah, so x is always going to be the x point?
Yes. Yep. Yes.
So that's why you didn't put x, or that's why you put 12 to get x instead.
Yeah, so if it's just f of x, that's just the derivative. That's the tool.
Y subtract equals. So it's no longer bottom, like the.
This guy here?
The line.
Yeah.
That's why you do. That's why you put x to the 12. Because it's always going to be 12.
Well, yeah, so now we use the point, right? The y goes with the y, the x goes with the x. So it'd be minus 140 minus 12, slope 24. Done. Okay. All right. I'm going to give you one more problem to do, and then we'll be done for today. Just want to give you one. I want to have you guys practice this kind of process. Okay, let's see here. So wherever you have, oh, there we go. Okay. So what you're going to do is, I need the slope of the tangent line at 3 points. When x equals 2, when x equals -4, and when x equals pi. Do I need an equation for this guy? No. I just need 3 slopes. That's it. Before I can find slopes, what do I need? The derivative. I need a derivative first. That's going to get you slopes. Derivatives get you slopes. So find derivative first.
Can we just do what you already previously mentioned?
What's that? Yes, but do it the other way because there's this one's a little. If it was like that, that would work, but it's going to be a little different this time. Yeah. Yeah, I know. Yeah. Yeah. Next week, you guys will be done by now. Okay, so we got x squared plus 8, or h plus x quantity squared. We've done that, I think, at least twice, probably more like 3 times. So I'm not going to do FOIL. I'm just going to do what I got. Just write down what I got earlier. I got x squared plus 2xh plus h squared, right? That's what that gave me. I'm going to run out of room very quickly. Okay. And then I'm going to distribute the -5, and I'm going to distribute the -1. So we get -5x minus 5h minus x squared plus 5x. Everything with an x, only x. Everything with only an x should cancel out. That's how you know you did it right. This guy has only x. This guy has only x. They cancel out. This guy has only x. This guy has only x. They cancel out. Everything with an h won't cancel out. Two xh plus h squared minus 5h over h. They all got h's. Factor up. So after all this, I have the limit as h approaches 0 for 2x plus h minus 5.
Will the limit always be h approaches 0, or will it never be like...
For these, yes. For the definition, it'll always be as h approaches 0, yeah. Yeah, I don't think I've ever seen a definition of derivative question where it was at h approaches 0, yeah. Plug in 0,
You get 2x minus 8.
you get 2x.
I wonder why it's 0, though, and not any other...
2x
Probably get rid of
minus
the
5.
from the equation.
What's the point of having it? You can get rid of it.
Once you've done that, plug in your numbers. So what are the 3? 2, -4, and pi. So f prime of 2 equals 2 times 2 minus 5, which is -1.
Mr. Flores, do we always have to write H, or could we just technically write it as 0?
No, always write h approaches 0.
Oh, no, like, in the equation, do we always have to write H, or could we just put 0 instead of H?
Where at? Where are you talking about?
Anywhere H is at? Because it's
Oh.
gonna be 0 anyway.
It's going to be 0. I mean, if that works, if it works, go for it. -4, 2 times -4 minus 5, -13.
Yeah.
And then the last one is pi. Pi is the easiest one because you can't multiply times pi, so it's just going to be 2 pi minus 5. Pi is 3.14, so it's 2 times 3-ish minus 5. So about 1-ish. Done. Okay. All right, guys. Okay, so Monday, I'll give you the practice.